This is part 3 of our lesson on solving trigonometric equations with factoring. We were in the middle of question 1b, and we stopped the video to start the next one because I have a time limit on how much I can post at a time on YouTube. All right, so at this point, we had cos x equals 5. We had cos x equals 1 over root 2, and cos x equals negative 1 over root 2. So in order to isolate or solve for x, I need to do the inverse cosine to move it to the other side. So for this first one, x is going to be the inverse cosine of 5. This one here, x is going to be the inverse cosine of 1 over root 2. And this last one, x is going to be the inverse cosine of negative 1 over root 2. Okay, so for each of these, we're going to go through and try to solve either by looking at the graph or by using a special triangle. So we're going to start with our inverse cosine of 5. I'm going to zoom in a little for this one. All right, so I have x equals the inverse cosine of 5. So if I were to look at the graph of cosine, which you have on your yellow sheet, but as I mentioned in a previous video, I don't have my yellow sheet with me, right? The highest my graph goes is 1. The lowest my graph goes is negative 1. So the only values that I can read off of the graph would be positive 1, 0, and negative 1. So I cannot use the graph for that. If I was looking at my special triangles, do I have a special triangle that has a side of 5? No, I do not. So I cannot use the graph, and I cannot use a special triangle because I don't have a special triangle with a side of 5. So I am going to make a little note to my future self that there is no special triangle with a side of 5. Which means right now, without a calculator, I would not be able to solve this. However, there is something that I can tell by looking at the graph. So as I said, I don't have a value of 5. I don't have a y value of 5 that I can read off of the graph. And that's because the graph does not go to 5, right? The highest the graph goes is positive 1. So it does not go any higher than 1. So I cannot actually do the inverse cosine of 5 because if I go all the way up to 5, there's no value for cosine. And even if I try it on my calculator, which I'm just switching it into radians, if I were to use my calculator and try to do the inverse cosine of 5, I will get an error. And that is because the number is bigger than 1. So when I'm doing these calculations, this number inside the argument has to be somewhere between positive 1 and negative 1. And if it's any bigger than positive 1 or smaller than negative 1, there actually is no solution. So it's not no solution because I don't have a special triangle. It's no solution because the number is higher than the cosine graph goes. So I'm going to say no solution for this part anyways. And I'm going to leave a note for myself that the graph does not go any higher than 1. So the graph only goes up to 1. 5 is way too high. There is no value. There is no possible way to get that number. Okay, so anytime you have a number bigger than 1 or smaller than negative 1 with cosine or sine, you are going to find that you have no solution. Tan is fine because tan goes all the way up to infinity, but sine and cosine are limited between positive 1 and negative 1. All right, we're going to then take a look at our 1 over root 2's. So I have x equals the inverse cosine of 1 over root 2, and x equals the inverse cosine of negative 1 over root 2. So looking at these two, you'll notice it's the same sides. So I am going to look for a triangle that has a side of 1 and root 2. And the triangle that has a side of 1 and root 2 is the one with the pi over 4s in it. So it has pi over 4, pi over 4. This is 1, 1, and root 2. Now, just because you have a triangle with sides of 1 and root 2 doesn't mean that it's necessarily a match. We need to pay attention to which sides are 1 and root 2. Cosine is the ratio adjacent over hypotenuse. So the 1 would be the adjacent side, and the root 2 is the hypotenuse. So here, the root 2 is the hypotenuse. The hypotenuse is the one across from the right angle, so that's good. Now the adjacent is 1. I have 2 1s. Does it matter which one I pick? Not really. I think I'm going to pick the bottom one to be the adjacent. I could pick this one to be the adjacent. It doesn't matter. If this is the adjacent, this one is the opposite. And then when we're trying to figure out the angle that was used to label this triangle, I always look what's across from the opposite, because the angle, right, the side across from that is always the opposite. So the one that was used was the pi over 4. So I know that the angle that we're using to calculate all of this was pi over 4. Now, it doesn't mean it's actually the angle pi over 4, but it could be a multiple of that. So what I need to do is then look at the cast rule and figure out which quadrants this angle could have come from. So I think I have enough space. I'm going to put the xy axes underneath each of these. Sometimes I'll do them up at the side, wherever you happen to have space. It doesn't need to be very big. All we're trying to do is identify which quadrants our angle could be in. So looking at my first one, this is 0. That's where my angles start. Full circle is 2 pi. And then just halfway is pi. And it's the same thing on this one. Okay. First one is 1 over root 2. It is positive 1 over root 2. So we are interested in where cosine is positive. So I'm going to use my cast rule. It starts in quadrant 4. We write C, A, S, T. So we're looking for where cosine is positive. So in looking at this, I see in quadrant number 1, A, they are all positive. So is cosine positive in quadrant number 1? Yes, it is. Is cosine positive in quadrant number 2? No, only sine is positive in quadrant number 2. Cosine would be negative. Is cosine positive in quadrant number 3? Nope, only tan is positive in quadrant number 3. Is cosine positive in quadrant number 4? Yes, it is. It's the C quadrant, so cosine is positive here. And then the pi over 4 that we found here is this little angle between our terminal arm and the x-axis. So to find my angles, they are always measured from the 0. So I'm going to try to use a highlighter this time. So the first one, it did not show up very well, starts at 0 and goes to my terminal arm. So that's that angle in quadrant number 1. And then my second one starts at 0 and goes all the way around to quadrant number 4 here. And then that's my second angle there. So I have an angle in quadrant number 1 and quadrant number 4. So I might zoom out a little. So I'm going to write quadrant number 1, quadrant number 4. Now in quadrant number 1, the closest x-axis is 0. So it is 0 plus pi over 4. Or just pi over 4. So x equals pi over 4. Do you need to write the 0 plus pi over 4? No, you could just write that it equals pi over 4. Okay, the second part, this one here, the closest it is to the x-axis is the full circle at 2 pi, but it's a little bit smaller than 2 pi, so it is 2 pi minus pi over 4. And then we want to get ourselves a common denominator, so this would be 8 pi over 4 minus 1 pi over 4, which is 7 pi over 4. So we have two options from this part. X could be pi over 4 or 7 pi over 4. Now the last part I need to do is the inverse cosine of negative 1 over root 2. It is the same triangle as this one. Cosine is still adjacent over hypotenuse, so this is still labeled correctly. Pi over 4 is still the angle that we used. What's different is which quadrants I would find the angle in. This time we are doing negative 1 over root 2, so we are looking where cosine is negative. Is cosine negative in quadrant number 1? No, they're all positive in quadrant number 1. Is cosine negative in quadrant number 2? Yes, only sine is positive in quadrant number 2. Is cosine negative in quadrant number 3? Yes, only tan is positive in quadrant number 3. Is cosine negative in quadrant number 4? No, cosine is positive in quadrant number 4. So I know the angle that we picked out is the pi over 4. And that is the angle that it makes with the closest x-axis. But our angles are always measured from 0. So this first angle is measured from 0 to my terminal arm, which is that angle there. That angle is a little bit smaller than a straight line. How much smaller? Pi over 4 smaller. So my quadrant 2 angle that we're calculating is pi, the straight line, minus pi over 4 because it's a little bit smaller. Now I need a common denominator. So pi is 4 pi over 4 minus pi over 4, which is 3 pi over 4. Okay, then we have an angle that is in quadrant number 3. I don't know if this is going to show up very well, but we're going to try. So it starts in quadrant number 1. Sorry, it starts at 0. It ends in quadrant number 3, and it is this big angle going all the way around there. Now that angle is bigger than the straight line at pi. So pi is the closest x-axis, but it's bigger than that, right? It's more than a straight line. So we're going to take pi, which is our straight line, and then add another pi over 4. So this last one is the angle in quadrant 3. X is pi plus pi over 4 because it's bigger than the straight line. I need a common denominator. So this is 4 pi over 4 plus pi over 4. And then 4 pi over 4 plus pi over 4 is 5 pi over 4. Whew, that was a lot of work. All right, so I have 4 different angles that came from that second bracket of 2a squared minus 1. And I have no solution that came from my first bracket because the number was too big for the cosine graph. So this part had no solution, so I don't have to worry about it. And then this part down here, we had pi over 4, 7 pi over 4, 3 pi over 4, and 5 pi over 4. So I am going to finish up just by saying, therefore, x equals. Now it's up to you. If you want to put them from low to high, that's great. If you don't want to, that's okay. But I think I might try to put mine in order. So I have pi over 4, that's the smallest, then 3 pi over 4, 5 pi over 4, and finally 7 pi over 4. All right, you have the rest of the period, I'm just going to zoom out a little here, to finish working on the questions that are on the front side of the page, and then I will see you tomorrow. Have a good day. Bye.